Okay, so number 37 is kind of an interesting problem. I made it up the other day, and looking back at it, I probably need to make things a little less sketchy as far as like figuring out your final bearing and where that final point would end up. And I also, my wording was kind of bad. It says, how far would the crow have to fly from its starting point to get to its initial spot? And I meant to say from its final position after the movement that's described in the problem to the initial spot. But anyway, okay. So I'm just going to start it off, and I'm actually going to end up drawing two different drawings of this because we don't know for sure, unless you get a protractor and you measure, you don't know for sure where you end up because you're just kind of sketching. So we'll just kind of play around with that and see what happens, okay? So 45 is in here, 30 is in here. Okay, so it says a crow flies for 70 feet at a bearing of north 28 degrees east. So north 28 degrees east, 70 feet. So north is this direction, 28 degrees east, so that's going to be something like this. And I'm just going to let some length be 70 feet. So this right here, this angle is 28 degrees. And this length right here is going to be 70 feet. Okay. Then it says, then it turns and flies 130 feet at a bearing of south 18 degrees west. So south 18 degrees west for 130 feet. Okay, so south 18 degrees west is going to be somewhere in here, right? So I'm going to go south and then 18 degrees west. 8s are never very bubbly, so it's hard to see that it's an 8. That made it so much better. Okay, 18 degrees west, and that's for 130 feet. So 130 feet is 60 more than 70 feet. So the question is, does it end up on this side of the vertical? Does it end up over here? Or, so I'm just going to kind of draw as if it does, okay? So I'm going to pretend like it stops right here, because I have no idea. I'm not measuring things. Or, so here's my vertical. Or, does it end up on the other side? I keep saying or, and then not finishing my statement. Whatever. Okay, 28 degrees, so I'm going to try and keep this similar. For 70 feet. And then for 130, so south 18 degrees east, so somewhere in here. Or does it end up past this vertical, which is very, oh, my vertical is no longer vertical. Does it end up past it, like somewhere over here, and that's it's still hard to see. Okay. I might have to exaggerate my 28 degrees a little bit. Okay. So my vertical is coming through here. The reason why I'm gonna keep that going is to emphasize the fact that if I end up over here, then my bearing to get from here to there is a different direction. You know what I mean? And I'll discuss that in a second. So I'm gonna exaggerate this for a second. I'm gonna exaggerate the 28 degrees, and then I'm gonna do that. So if it like ended up over here, like, so that would be the exaggerated form of what I just talked about, okay? And the scale is messed up, it's not great, but I'm just gonna, I don't know, we'll see. You can see it over here. This one's kind of hard to see, so I'm gonna exaggerate a little bit. Okay, so let's talk about what I know. In this triangle right here, so far 130 feet. I know two different side lengths. I know this side length right here, and I know this side length right here. So I know 70 feet and I know 130 feet. And then I also know one angle in this triangle right now. I know this angle right here. So let's talk about how I know that angle, okay? If I have two verticals, and I'm crossing, like I'm going from one at a bearing of 28 degrees, right? So I'm going to pretend like this is this. So here's my 28 degrees, right? Well, that means this right here is 28 degrees. So that means all the way from this vertical, which doesn't look very vertical now that I look at it, this vertical all the way to here is 28 degrees. This piece right here is 18 degrees, which means this right here is 10 degrees. So when I think about what I know in this triangle, it looks like I know an angle, and then I know the two sides on either side of it. So I know two sides and the included angle. I don't know this angle, which goes with this side. I don't know this angle, which goes with this side, but I do know this angle, and I don't know that side, which means I do not have an angle in a side pair. So this is definitely going to be law of cosines if I need to figure out this length. So let's think about that. It says, or read the question. How far would the crow have to fly from, again, its final position, this point right here, to get to its initial spot? So I need this length. Oh my gosh. Okay. That was loud. Okay, so it's either this length right here or it's this length right here. Kind of depends on, and I won't know until I know this angle right here. Okay? So, here's what I'm going to do. I'm going to use law of cosines to find this side length. I'm going to label this A, B, and C for starting point, and the next point, and then the final point. And then, okay, I'm trying to find side B. So side B is the square root of A squared. A squared is going to be 130 squared, plus C squared, which is going to be 70 squared, minus 2 times A, 130, times C, which is 70, times the cosine of angle B, which is 10 degrees. So I'm going to type that in, and that's going to give me this side length, okay? So the square root of 130 squared plus 70 squared minus 2 times 130 times 70 times cosine of 10 degrees. And that gives me 62.262. 62.262. So 62.262. There's some symmetry in that. Okay. So 62.262, and that's going to be feet. So how many feet? It would have to travel 62.262 feet to get from its from point C back to its initial, or I guess I could say back to its initial, its initial point, initial spot. But then it says, and at what bearing? So here's the kicker. If I am going from here to there, then I am traveling northwest. But if I'm traveling from here to here, then I'm traveling northeast. Yeah? So what I need to know is, this angle, like, I need to know what it is, because if it plus 28 is still less than 180, then I am to the right of A. I am to the east of A. But if this angle plus 28 is more than 180, then I am to the left. I am to the west of A. Okay? So, in my triangle, let's talk about what I know. I know a side length, and I know its angle. I know this side length, and I know the opposite angle. So I have an angle and a side pair, which means I can use that angle and a side pair and this side length to find this angle, angle A. Okay, so angle A. If we're going to try and find an angle, we got to start with the sine of the angle on top. So sine of angle A over side A, 130 feet, equals, and so the other side and angle pair, we're going to use 10 degrees and 62.262 feet. Okay? I need to solve for angle A, so I'm going to multiply by 130. And then that undoes the division by 130, and then I need to undo the sine of angle A, and the inverse of sine is sine inverse, or arc sine. Okay, so let me type that in. Sine inverse of 130 times sine of 10 degrees divided by 62.262. 130 times sine of 10 degrees, yeah, okay. And I get 21 point, oh, interesting. Oh, did I create a situation where I've got more than one? Sine of angle A over 130. That doesn't make sense. Is this one of the situations where I could have more than one? 10 degrees, 130. So 130 is coming off it. Sorry, I'm thinking to myself. Okay, it's giving me the acute, and I need the obtuse. That's annoying. Okay. I'm going to see if I can't get, I'm going to do law of cosines with this to find angle A using these three side lanes, okay? So, give me a second. I'm going to see if I can't, because this is, what's happening is it's doing this situation kind of backwards of what we've done before. I've got 10, I've got 100, well, that 130 is in there. I don't know why this is, oh, so it's saying that this, it doesn't know how long this is, so it's saying it could be here or it could be here, which is making angle A be that acute. Oh, well, all I got to do then is 180 minus what I just got. Let's see, 180 minus, okay, I'm pretty sure this angle right here is supposed to be 158.74, okay. I'm going to see if I get that using law of cosines. So, give me a second. And then I'll fully explain that if I don't get it. Okay. So, if I need angle A, then I need A squared equals B squared plus C squared minus 2BC times the cosine of angle A. A is going to be 130, so 130 squared equals B squared, which is 62.262 squared plus C squared, 70 squared, minus 2 times B times C, so 62.262 times C, which is 70 times the cosine of angle A. And then I'm going to solve for angle A. So I'm going to subtract 130 squared minus 62.262 squared minus 70 squared divided by negative 2 times 62.262 times 70, and then we're going to take the cosine inverse of all that, and that will be angle A. So cosine inverse of 130 squared, just kidding. Cosine inverse of 130 squared minus, what did I do first? Yeah, 62.262 squared minus 70 squared divided by negative 2 times 62.262 times 70, and that should be good. Yep, 158.7396, and that is basically what I got up here. There's a difference in up to a hundredths place, but that's because I've rounded the 62.262 and depending on the different format we're doing. Okay, so let me explain why the law of sines didn't work. Okay, so law of sines saw this. I gave it a 10-degree angle, and then I said, okay, let this length be 130 feet, not degrees, and then I said, let the side length coming off of it, this right here, be 62.262. So the problem is that 62.262 could swing here and it could swing here. So what it did was, we were trying to get this one, and it was giving me this, so it was giving me this acute angle, right? Well, I guess I needed this angle. I needed this angle, and it was giving me this angle. Just kidding about that one. So what I needed was, if I knew this angle, and law of sines told me that that was 21.258, then I knew that this was also 21.258, so this was 180 minus it, which was 158 point. Now, I'm going to go with the law of cosines one, but they're very similar. So it's 0.73, or 740, because it rounds up on the law of cosines. Okay, so not quite the same. They don't quite match, but it's fine. So this, if you rotate it, I don't know why I just said it like that. This was my angle A that I needed. I hope that makes sense to you, this one right here. And what it was giving me was angle A as if it was down here, as if this swung over here as opposed to swinging here. So law of sines is kind of, you know, it's got its issues. You know, depending on what you're given, you could get the acute when you need the obtuse. Okay, so let's go back to this. So I found this angle using law of cosines, and I found that it's 158. We're going to go with 158.74 feet. It's an angle, Jennifer. 158.74 degrees. Okay, so this right here is 158.74 degrees. Or this right here is 158.74 degrees. So let's talk about which one makes sense now. If I add 158 plus 28, and I get more than 180, then it has to be this situation over here. And we do, right? 158.74 plus 28 is 186.74. So that means between this obtuse angle right here and the 28, I should get more than 180, right? This right here says, hey, you still have a little bit left when you add this one and this one. You should have a little bit left from 180, but I don't, which means I have it over here. So that means that this extra piece right here, this plus this, is 186.74. So if you think of it like this plus this is 186.74, which means this angle right here is 6.74 degrees. Because all of this and 28 is 186.74 degrees, which means here's the 180, here's the 6.74 degrees. Okay, so why is that important? Okay, so I'm gonna exaggerate that triangle down here. I'm gonna do it again. I've got bump, I've got bump, and I've got this, right? I've got this angle right here is 6.74, and my last piece of this was to find the bearing from this point to this point, from C to A. So here's what I need to know. I need to travel north, and then I need to travel this many degrees east. Well, here's what I've got. I've got an alternate interior set of angles. If this right here is 6.74, then so is this right here, 6.74 degrees. So my bearing is going to be, we're going to travel 62, so it's not this one. We're going to travel 62.262 feet to get from point C to point A at a bearing of north 6.74 degrees east. North 6.7274. degrees east. And I hope that makes sense. It was what I want to change about this problem for the future, since you guys are the guinea pigs on this, is I'm probably going to make this angle sharper at 28 degrees, make it maybe out here some more so it's a little bit easier to tell. And I'll either make the length quite a bit longer, like 3 times longer, or shorter so it lands over here. It lands definitely over there. Because this is a little tricky, not going to lie. Especially with law of sines giving me that situation where I have 2 different triangles. But anyway, that is number 37. And I hope it helps. And if it doesn't, well, just remember you don't have to take a test over it. So there you go. All right, goodbye.